Clark transmissions have been available in GMC trucks for years. The Clark 280V and 280V HD have been installed in 1 million medium-duty trucks over the past 16 years, ours and others. The new Clark 5-speeds, the CL450 and CL550 series, are now available transmissions in 6000 and 7000 series GMC mediums. They're included in a large number of our easy spec models. Why? Well, one reason is timing. New state-of-the-art transmissions don't come along every day. It takes a great deal of money and time to develop and test a new transmission. These Clarks are new transmissions. The CL450 is totally new. The CL550 is not completely new, but is the next generation of the Clark 390V, a sound transmission made better. These are constant mesh transmissions. These transmissions shift not by moving gears into contact with other gears, but by locking and unlocking the gear to the shaft, so there is less chance of breaking gear teeth. Because of the constant meshing and the design of the gears themselves, it is possible to make the overall package size of the transmission smaller without losing any of the strength or torque capacity of a larger and heavier transmission. Clark's a long-time truck supplier. Like us, they have a lot of real-world experience. We thought it only fair to let them brag a little bit about themselves before we get to the serious studying. So please, look at the next segment and see how Clark sees itself.
We are Clark Automotive Products Corporation. We're a part of the Clark Equipment Company. Our headquarters is in Kalamazoo, Michigan, between Detroit and Chicago. Clark has produced over 5 million 5-speed transmissions since 1927. In 1983, Clark sold 38% of the medium-duty transmissions in classes 6 and 7. That's the biggest share taken by any transmission manufacturer in those classes. We believe that our new truck 5-speeds are the result of best available technology. As a result, the new CL series transmissions have a high torque capacity to weight ratio. The gears are computer designed and shot peened. This makes it possible to use smaller gears with greater resistance to metal fatigue. The transmissions have high capacity needle roller bearings under all main shaft gears. The synchronizer design is new. Synchronizers are simpler and more durable and larger. They compare in size to those used in much higher capacity transmissions. Shift controls are completely redesigned to make shifting easier, more consistent. The transmissions have positive torque lock. This increases the resistance to gear jump out as the amount of torque from the engine increases. The higher the torque, the more secure the gear engagement. For certain applications, we've developed soft fourth gearing. Soft fourth gearing can be used with either a single-speed or two-speed rear axle. When used with a two-speed, the shift pattern is progressive, with no tricky swap shifts in the higher gears normally associated with short fourth shifting, so shifting is easier and more natural. Finally, there's our quality assurance program. It's one of the most stringent in the industry. We evaluate the effectiveness of our shot peening process on a regular basis. We routinely test our end products on the dynamometer, in engineering audits, and in vehicle testing. We give a loaded spin test to every transmission in every gear before it leaves the plant. We're very serious about these things because we have just one goal: to make the best transmissions in the world. We would now like to show you the power flow through the transmission as you shift it. We'll use this working cutaway of the CL450. It is now in neutral. In neutral, with engine running and clutch engaged, the input shaft and main drive gear turn the counter shaft. The counter shaft turns the main shaft gears, but since the main shaft gears are rotating freely on the main shaft, no power flows beyond the counter shaft. please shift it to first gear by pressing button number 1 on your touchpad. When you shift into first gear, the first and reverse shift fork moves forward, locking first gear to the main shaft. Power flows in through the main drive gear, down to the counter shaft, then back up to the main shaft through first gear. Power is now being transmitted through the main shaft at the first speed gear ratio. Now to shift to second, please press touchpad button number 2. When you shift into second gear, first gear is unlocked from the shaft and the second speed synchronizer moves rearward, locking second gear to the main shaft. Power flows in through the main drive gear, down through the counter shaft, and back up to the main shaft through second gear. Power is now being transmitted through the main shaft at the second speed gear ratio. To shift to third, please press button number 3. When you shift into third, the second third gear synchronizer moves forward, unlocking second gear and locking third gear to the main shaft. Power flows from the counter shaft up through third gear and is transmitted at the third speed gear ratio. To shift to fourth, please press button number 4. When you shift to fourth, the second third gear synchronizer assumes a neutral position between second and third gears, and the 4/5 synchronizer moves rearward, locking fourth gear to the main shaft. Power then flows in through the main drive gear, down to the counter shaft, then back up through fourth gear, and is transmitted to the main shaft at the fourth gear ratio. To shift to fifth, press button 5. In fifth gear, the 4/5 synchronizer moves forward, locking the input shaft and gear to the main shaft. Power flows straight through from the input shaft to the main shaft at a 1:1 ratio. We'll now shift the transmission to neutral. To see the power flow in reverse, press touchpad button number 6. In reverse, the 2, 3, and 4/5 synchronizers are in neutral. The first and reverse shift fork moves rearward, locking reverse gear to the main shaft. Power then flows in through the main drive gear, down through the counter shaft to the reverse idler gear, then up to the main shaft through reverse gear. The reverse idler gear reverses the direction of rotation of the main shaft. For an explanation of how a synchronizer works, please view the next segment of this disc. With a constant mesh transmission, the gears on the counter shaft, which are driven by the engine, are always turning the gears on the main shaft. But the main shaft gears are not attached to the main shaft. They roll freely on bearings. When you shift, the appropriate shift rail slides a shift fork rearward or forward. This locks the appropriate main shaft gear to the main shaft and drives the main shaft, which drives the truck. Synchronizers are used to lock the main shaft gears to the main shaft in Clark 5 speeds, except for first and reverse. The synchronizer is fastened to the main shaft, and the main shaft is always attached to the truck's drive wheels. The synchronizer rides on a sleeve that's splined to the main shaft. The shift fork can move the synchronizer slightly, backward or forward, on the sleeve. Whichever way it moves, the outer ring of the synchronizer touches the lip of the cup on the main shaft gear. Before the ring and lip touch, the synchronizer is being driven at the drivetrain speed of the truck's rear wheels, and the main shaft gear is coasting, because the truck's clutch has been disengaged in order to shift gears. When the ring touches the lip, it starts to spin the gear. When the gear speed matches the synchronizer speed, which is almost instantly, the synchronizer moves still closer to the gear and slides over to lock onto matching teeth on the gear. Now, with the clutch engaged, the countershaft gear turns the main shaft gear, which turns the synchronizer, which turns the main shaft, which turns the truck's rear wheels.
You can offer the all-new Clark CL450 transmission in GMC mediums with constant mesh, all helical gearing, shot-peened gears, new split-pin synchronizer design, positive torque lock, and reduced shifting effort. For details, please select one of these design areas and press the corresponding number button on your touchpad. Thank you. CL series transmissions use an aluminum clutch housing and aluminum top cover. The large top cover permits repair or replacement of the shift controls and inspection of main shaft gears and synchronizers without removing the transmission from the truck. Shift controls have been completely redesigned. The new control assembly features round rather than stamped rails and a forged first reverse fork to promote consistent shift. The CL450 has 25% less shift lever side travel than the 280V. This keeps the lever closer to the driver, so shifting is less tiring. Improvements in detent forces and ramp angles in the shift control also contribute to ease of shifting. Most of the holes in the transmission case are blind. That is, they don't penetrate the case. This avoids creating a potential leak point. Where fasteners do penetrate, they are sealed to prevent leakage. The interior of the case is painted. This is a feature usually found only on larger, more expensive transmissions. This special painting guards against porosity leakage. CL series transmissions use a tapered roller bearing to support the input shaft, a quality feature. Tapered rollers are more tolerant of thrust loads and pounding than simple ball bearings, since the pressure can be spread out over a larger surface area. This input shaft support shows the large surface area of the bearing race and the lubricating oil slot for the bearing. In the spigot bearing, uncaged straight rollers are used, held in place by a flat retainer and snap ring. In a given space, uncaged rollers can be larger than the cage-type roller bearing used in this location on some transmissions. Synchronizers are a vital part of a transmission. The synchronizer's sole function is to enable the driver to shift gears in a single motion without hesitation or double clutching. The CL series transmissions use a new synchronizer design, relatively large in comparison to gear size. That in itself improves shifting ease and durability. The new synchronizer uses a special aluminum silicon alloy clutching surface that has shown in tests to be much more durable than the previously used bronze component. The large cone diameters increase synchronizing ability and contribute to long life. The Clark synchronizer consists of 2 hardened steel cups splined to the main shaft gears, 2 aluminum alloy clutching members, and a hardened steel center plate with spline bore. 3 split pin assemblies allow the center plate to move toward the cone as the plate slides either forward or backward to perform the clutching action between gears and main shaft. 3 super hard blocker pins hold all parts together, providing a strong and durable synchronizer assembly. Clark's positive torque lock feature is an effective way of preventing a transmission from jumping out of gear. This sleeve is splined to the main shaft and supports the synchronizer. The center of each tooth has a depression, which in effect widens the tooth in that area. Before it can jump out of gear, the synchronizer hub must climb over the thicker portion of the tooth. The greater the torque being transmitted through the synchronizer, the greater the resistance to jump out, hence the term positive torque lock. CL series transmissions feature positive torque lock in all gears. CL series transmissions feature constant mesh, all helical gearing. There are no sliding gears, no spur gears. With no gears sliding in and out of mesh, there's little risk of gear tooth damage. Constant mesh gearing also makes shifting easier. Spur gears have straight gear teeth cut parallel to the center line of the gear. The CL series computer-designed all helical gearing provides quieter operation compared to spur gears. Constant mesh gearing also means easier shifting in first and reverse. And the reduced inertia levels made possible by the use of smaller, lighter gears also helps to reduce shifting effort. Moreover, Clark helical gears have fewer teeth for a given diameter than competitive designs. Therefore, the base of each tooth can be wider and the tooth profile shaped to provide maximum strength under load. The gears are shot peened. In this process, the surfaces of the gear are bombarded with very hard, tiny steel balls which increase the compressive residual stress on the gear surface. Clark uses heavy-duty anti-friction bearings extensively in the new CL series transmissions. High-capacity needle roller bearings are under all main shaft gears. Needle rollers provide the best combination of compact size and high load carrying capacity. Another reason for the high CL series torque capacity to weight ratio. The clutch housing on CL series transmissions, as well as the top cover, is a lightweight aluminum casting. The countershaft in CL450 series transmissions is supported at both ends by long-life tapered roller bearings with positive lubrication at all critical bearing locations. These large bearings have more bearing contact surface over which to spread the load. Countershaft gears are in constant mesh with gears on the main shaft. The use of constant mesh gearing in all gears, including first and reverse, eliminates gear clashing and possible tooth damage. The Clark units come with two power takeoff openings, one on each side of the transmission. Clark decided on two 6-bolt PTOs because this type handles 90 to 95% of the needs of medium-duty users. CL series transmissions have a cast iron gear case. The fins on the outside of the CL450 case are not just for cooling, but to strengthen the flat surfaces and reduce noise without having to make the case heavier. Trying to make a better transmission by designing a better transmission is just the start. Testing the design is equally important. To hear some of that story, please play the next segment. Thank you. Following the development phase, the new Clark transmissions were tested in the laboratory and in the real world of city streets and mountain highways. The on-road testing program began in June of 1981 when a CL450 was installed in a medium-duty delivery van. It ran day in, day out for 50,000 miles, carrying a full payload over city and suburban routes, under conditions estimated to be 2.5 times as severe as normal. When torn down and inspected, engineers could see no signs of abnormal wear. A CL450 was also tested in a tractor-trailer rig, driven over 60,000 miles in mountainous terrain in service estimated to be 5 times as severe as normal. In a later phase of the program, the CL450 was tested and evaluated in over a dozen fleets in various parts of the country. Overall, the results were very positive and established a high degree of confidence in this new transmission.
A 5-speed is the most widely used medium-duty truck transmission by a big margin. Many are used in combination with a 2-speed axle, which adds a lot in terms of versatility and efficiency at relatively low cost. But GMC mediums offer a choice of 5-speed transmissions and 2-speed axles, and not all applications require a 5 and 2 combination. Determining how the vehicle will be used is the logical starting point in choosing the right driveline combination. No, you've made a good you're probably overspecking. A 4-speed transmission with a single-speed rear axle, the standard driveline in all GMC mediums except the 7000 series tandem, is suitable for light-duty cycle applications, on-road delivery jobs with loads not exceeding about 20,000 pounds GVW. One of the higher numerical axle ratios should be selected for heavier loads or if the truck has to negotiate steep ramps or hilly terrain. A two-speed axle would improve this vehicle's performance capabilities quite a bit, making it suitable for on or off-highway jobs with loads at or near the vehicle's GVW rating. A high numerical axle ratio would be a good choice if the vehicle were used off-highway to a great extent. A five-speed is really all you need. Transmission with a single-speed axle, it works well for city and highway applications with moderate loads. Of course, adding a two-speed axle can make it a better performer with heavy loads in hilly terrain, starting heavy loads on ramps, or working at off-road jobs. It's also better for one-way loaded operations where all available gear combinations are used when the vehicle is loaded and just the fast ratio when the truck is empty or under light load. That's our recommend. The 5 and 2 combination is widely used in tractors as well for city and suburban delivery applications, and also for highway units. A good place to get a feel for customer transmission preferences 6 and 7,000 series conventionals is in the easy spec section of your data book. The CL550 series transmissions are the popular choice with the CL427 gas engines, the 8.2 turbo diesel with a 2-speed rear axle, naturally aspirated 366 gas engine. You will find generally that the CL450 and CL457 transmissions are most popular in combination with a 2-speed rear axle choice with either a 366 gas engine, the 8.2 turbo diesel, naturally aspirated diesel, and the 3208 naturally aspirated diesel. One of the many design refinements of the new CL series is soft fourth gearing. A CL series transmission with soft fourth gearing works well with either a single-speed or two-speed axle. With a two-speed, soft fourth gearing provides a progressive shift pattern that's less confusing and much easier to use than the commonly used short fourth gearing. A short fourth transmission with two-speed axle allows utilization of all 10 gear ratios. However, it requires a somewhat tricky swap shift in fourth and fifth, as shown, to split the axle ratios. The shift sequence is 4 low, 5 low, 4 high, 5 high, a tedious procedure and sometimes confusing for inexperienced drivers. Soft fourth gearing, on the other hand, provides 9 gear steps instead of 10, but much easier shifting. There's no 4-5-4-5 swap shifting. The shift pattern is progressive throughout, with an easy 4 low, 5 low, 5 high sequence in the top 2 gears.
Your major competitors, Ford and IH, offer the new Spicer CM40 transmission in their mediums. It too is a constant mesh, all helical geared transmission synchronized in 2nd through 5th gears. Both Clark and Spicer are designed to handle the torque output of the gas engines normally used in mediums and diesels at the lower end of the power range. The CL450 has a torque capacity rating of 405 pounds-feet. The CM40 is rated at 420 pounds-feet. A major design difference is the CL450's cast iron gear case with aluminum top cover. The Spicer gear train is housed in a 2-piece aluminum case. The top-loaded Clark case and large top cover permit inspection of gears and synchronizers without removing the transmission from the truck. The only way to inspect internal parts of the Spicer transmission is to remove it from the vehicle and disassemble it. And the aluminum case must be handled with special care. Nicks or gouges on mating surfaces could lead to leakage problems, and extra care must be taken to avoid stripping the threaded holes in the case. An additional point in favor of the Clark iron case is that most bolt holes are blind, so there's no possibility of fluid leakage at these locations. The Clark shift controls have been upgraded from a stamped rail to a round rail design to promote easier shifting and greater durability. Shift controls and shift fork wear pads are accessible for adjustments or repairs should it ever become necessary. The Spicer must be removed from the truck and disassembled to gain access to the shift controls. An important factor in the life of a transmission is bearings. Now, that's why Clark uses large anti-friction bearings in key spots on main, counter, and input shafts. You'll find long-life tapered roller bearings on the Clark input gear, main shaft, and both ends of the counter shaft. They have more bearing contact surface over which to spread the load. In the Spicer transmission, you'll find tapered roller bearings on the counter shaft, but ball bearings on the input gear and main shaft. Clark uses needle bearings under all main shaft gears. The Spicer has needle bearings only under first, second, and reverse gears. Third and fourth gears ride directly on the main shaft. The CL450 uses small diameter gears with high strength tooth profiles. Gears in the Spicer unit are larger in diameter. Large diameter gears have a lot of inertia. Small gears have much less, so the Clark synchronizers have less work to do. Spicer has developed a synchronizer for the CM40 similar in design to the Clark, but it uses the bronze clutching surface which Clark has discarded in favor of the new aluminum silicon alloy. And although the synchronizers are similar in size, with the lower inertia levels, gears to aluminum alloy clutching members.